right, fantastic. All right, so we should be recording now. Everybody should be able to see me and hear me. Hello. Happy Monday. This is Monday, March 30th. This is A4 Precalculus CP. Today what we're going to be learning is we're going to be learning something called the law of sines. Just a couple of reminders before we get started. Please make sure if you haven't done so already, you make sure you mute your microphone and disable your webcam. If you have any questions during this, feel free to unmute yourself and just chime in. Don't worry about having to interrupt me or anything like that. Just say what you need to say. Also, you can type it in the chat if you don't feel comfortable with voice, talking over voice. Make sure you fill out the attendance form on Google Classroom just to indicate that you were present today. Additionally, last class I assigned a little bit of a homework assignment for you to do. There were 7 problems on the area of triangles using the 1/2 AB sine C formula to find the area of those triangles. I am going to go over questions on that during my faculty office hours today. That's from 1:30 to 2 o'clock p.m. So if you'd like to stay afterwards and you have any questions about that, I'd be happy to go over them. I also posted the answer key for you so that you could check out that answer key, and that would hopefully clarify any questions that you do have. I posted it this morning around like 7:45 in the morning. But if you do have any additional questions beyond those, you are more than welcome to stay and just ask me directly. All right. But I do want to maximize the amount of time that we have to teach you something today, and that something that I want to teach you is called the law of sines. All right. One thing I want to mention, one more thing before getting started, is today I'm going to be talking about the law of sines with you. Just like last time, I'm going to give you a little assignment to do. I think I might have already posted it too. That's going to be due for next class, so please make sure you get that done. I'll post an answer key on that as well, just like I did with this one. So we should be all set with that. The next class, I'm going to talk about something called the law of cosines, because there's a law of sines and the law of cosines. On Friday's class, there will again be another little assignment for you to do. Friday's class is really going to be sort of a wrap-up class to review the area idea of 1/2 AB sine C, this law of sines idea that I'm going to introduce to you today, and the law of cosines idea that I'm going to introduce to you on Wednesday. So Friday's class will be pretty much like a review, like does anybody have any questions, just a culmination of everything. Additionally, on Friday, I am going to assign to you a progress assessment on this stuff. The progress assessment is going to be a document on Classroom that I share with you, and I'm going to ask you to take a picture of your work and send it to me via Google Classroom, just like how you would submit an assignment for another class. Okay? We will have a summative assessment on this stuff eventually. At this time, I don't know what summative assessments will look like, but I'll make sure to let you know as soon as I know. And it is really important that you take the progress assessment seriously because, like I said, you will have a summative, so it's important that you get that practice and take that practice seriously, and do ask me any questions if you have any questions. Okay? So that's really what we'll be doing the next couple of classes going forward. Again, today is law of sines, Wednesday is going to be law of cosines, and then Friday is sort of a wrap-up class. I'll assign a progress assessment at the end of class. That progress assessment will be due on Tuesday because that is the next time that we meet each other. All right? So hopefully no questions on that. If you do have a question, I'll be happy to reiterate that. But let's get started with some learning, and let's talk about the law of sines today. All right. Now, the law of sines is a way for us to find missing sides and missing angles of a triangle. Okay, that's really what the law of sines is all about. There is a long explanation that exists. It's a very interesting explanation, I think, as to how to prove the law of sines and where it comes from. But since we only have a limited amount of time together today, I do want to just dive into some examples and demonstrate it to you. If you're interested in the why it exists and where does it come from, I am going to link a really great video on Google Classroom that you can watch on your own time if you so desire, explaining the proof of it and where it comes from and stuff like that. So I'm not really going to focus on that today, just going to focus on some examples. So let's get started. The law of sines, in case you're wondering what it actually is. If I have a triangle, just some random triangle ABC, right? Since I labeled my triangle this way, that means that side A would be across from angle A, side B would be across from angle B, and side C would be across from angle C. The law of sines states that the sine of angle A divided by the side A is equal to the sine of angle B divided by the length of side B, and the sine of angle C, going off the paper a little bit, divided by the length of side C. Okay? So that ratio exists with every triangle, that the sine of any angle divided by the side that's across from it is equal to the side of any angle divided by the side that's across from it throughout the entire triangle. Okay, that is a relationship that just is established and exists. It's called the law of sines. So we can use that law of sines to solve for any missing side and any missing angle in any triangle, not just right triangles. We can use it for literally any triangle. So let me show you an example of what that looks like. Okay, if I told you to solve the triangle. Now, when I say solve the triangle, what that really means is you're trying to find all missing sides and all missing angles. So it's very important that you understand that just that terminology of solve the triangle means we're looking for all missing sides and all missing angles of the triangle. You want to be able to state what the measurements of all sides and angles are. Okay? And say we started with an example like this. Okay, here's my random triangle. Not trying to draw it to scale or anything like that, just a random triangle. I have my triangle A, B, C. And if I started with saying angle A was 60 degrees, angle C was 40 degrees, and side A across from angle A was 8 units. All right, and I asked you to solve that triangle. What you could do is you could use the law of sines to figure out what is side C equal to and what is side B equal to, and also we can figure out what angle B is equal to. All right, first things first, your eyes should be drawn to things that are across from each other, because if you notice in the law of sines, things that are across from each other match up like this in this ratio. So my eyes are drawn to this angle measure of 60 degrees and this side length of 8 units. Additionally, my eyes are drawn to this, where we have a side length, an angle measure of 40 degrees and an unknown side length. So I can use my law of sines, which I just have up in the top right corner for you, to find out what that missing side C is. I can say that the sine of 60 degrees over 8, that's your sine of A divided by A, should equal the sine of 40 degrees over C, because we don't know what side C actually is, right? So that's what we're going to try to do first. A little bit of cross multiplying here. Essentially, you're multiplying both sides by 8 and multiplying both sides by C to get rid of those fractions. This is going to become C times the sine of 60 degrees is equal to 8 sine of 40 degrees. I'll make sure I keep that paper straight. Divide both sides by the sine of 60, we get C is equal to 8 sine of 40 divided by the sine of 60. I can go ahead and plug that into a fancy schmancy calculator. Didn't have my graphing calculator last time, but bam! We got graphing calculator this time. Here we go. We got that 8 sine of 40 divided by sine of 60. Making sure we're in degree mode, by the way. Let me make sure I can move it out of the glare so you can see. And we get that C is approximately equal to, we'll call it 5.9. Okay? So C is about 5.9, side C. All right? Now, what we have left to solve for is angle B and side B. Angle B we can actually get right away, because if you notice, all of the angles in a triangle have to add to 180 degrees. There's no ifs, ands, or buts about that. That is an established fact from geometry. So if this angle is 60 degrees and this angle is 40 degrees, then we could very quickly say that this angle is 80 degrees, because that's what would total our 180 degrees to create that triangle. Right? Now that we know that, we can return to the law of sines and say that the sine of this divided by this should equal the sine of this divided by this, and that will help us get that unknown side. So again, the idea is we're trying to solve for all of the missing sides and all of the missing angles of the triangle. I can now say that the sine of 60 degrees over 8 is equal to the sine of 80 degrees over B, because I don't know what side B is. And we'd solve for it much in the same way as side C. In case you're wondering, yes, I could certainly use this pair, the 40 and the 5.9 here, instead of the 60 and the 8. The reason why I did not do that is because, number one, we approximated this 5.9, so I'd much rather use something that's given to me rather than something that I approximated. It'll probably result in a more accurate answer. And number two, because the sine of 60 degrees is a nice, easy value to figure out, right? We all know the sine of 60 degrees is rad 3 over 2, of course. So that makes my calculation a little easier to work with. But I always recommend working with stuff that's given to us first. That's always like the baseline that I compare everything to. So I'm going to go ahead now and just solve this. I get b sine of 60 is equal to 8 sine of 80. Divide both sides by the sine of 60. You get b equals 8 sine of 80 divided by sine of 60. Go ahead and plug that into our fancy schmancy calculator. I get 8 sine of 80 divided by sine of 60. And that's equal to, we'll call it 9.1. So b would equal approximately 9.1. And we've now solved for all of the sides and all of the angles of that triangle. Does that make sense to everybody, how that was done? And if not, again, please feel free to chime in with a question. Processing, thinking about it, sitting on it. This is good. This is good. Again, if you have a question, please feel free to unmute yourself and speak up, or just type it in the chat, either way. All right. Let me show you another example of the law of sines in action. All right. Another example where I'm just going to say solve the triangle. In this example, we'll say we have a triangle kind of like this. Again, not trying to draw these triangles to scale. They're just random triangles. Certainly by no means right triangles. I have A, B, and C. If I told you that angle A was 30 degrees, angle C was 45 degrees, and I told you that this side was 2. Okay? I should be able to find all of the other sides and angles of the triangle. First things first, I'm again looking at things that match up. This 30 degrees matches up with the 2. The 45 degrees matches up with this side that I currently don't know. So we can go ahead and find that side by saying the sine of 30 degrees over 2 should equal the sine of 45 degrees over C. Solving for C, I would get C sine 30 is equal to 2 sine 45. Divide both sides by the sine of 30, you would get C equals 2 sine of 45 divided by the sine of 30. What's actually pretty cool about this is you could solve this by not even using the calculator at all, because those are both special angles on the unit circle. The sine of 45 degrees is rad 2 over 2. The sine of 30 degrees is 1/2. So you could solve this by saying this is 2 times rad 2 over 2 divided by 1/2. The 2's cancel out. You'd get rad 2 divided by 1/2. To divide by a fraction, you multiply by the reciprocal and say this is 2 rad 2. Okay, which is kind of cool. Certainly you can use a calculator if you need to, but using your unit circle knowledge actually makes this a little easier. And you could say that this is 2 rad 2. Makes it so we don't even need that calculator. All right, that's certainly not going to be the case all the time. In fact, it will probably be the case in the minority of times that we have all angles that just so happen to reside on the unit circle as those specially defined ones. But if you notice that, it's a nice handy little shortcut. All right, now again, we can go ahead and get these two that we don't know. If this angle is 30 and this angle is 45, then angle B has to be 180 minus, it looks like 75. So I believe that's 105, right? And so if I know that that's 105 degrees, then we can find this by saying, again, just referring back to our sine A over A, sine of 30 over 2 is equal to the sine of 105 over B. Just solve for B just like we did before. I can say multiply both sides by B and by 2. B sine of 30 is equal to 2 sine of 105. Divide both sides by the sine of 30, you get B equals 2 sine of 105 divided by sine of 30. And so B, again, using our handy dandy calculators, we could say that B is 2 sine of 105 divided by the sine of 30 degrees is 3.86. We'll call that 3.9. And we've now succeeded in solving for all of the sides and all of the angles in that particular triangle. Does anyone have a question as to how that was done? Again, I'll give you a couple seconds to soak it in and ask. Feeling pretty good, making sense. I take your silence as no questions. All right, great. So these two examples that I've given to you are examples in which I've given you two angles and one side. And I think when you get two angles and one side, I think these problems are what I'd consider straightforward problems. There's no questions really as to what to do. There's no ambiguity at all. You just go ahead and solve for the two sides and the one angle that you don't know. You don't really have to ask yourself any big leading questions, right? So I'd consider these problems to be straightforward. Straightforward. Okay. However, if I am given two sides and one angle, is that how you spell forward? Is it forward? I don't know. Whatever. Not an English teacher. Two sides and one angle. That is where I would consider these to be ambiguous. And in the world of mathematics, when you're given two sides and one angle, as opposed to two angles and one side, that's what's called the ambiguous case of the law of sines. The reason why it's called the ambiguous case, ambiguous is just a big word that means you're not really sure whether it's one thing or the other. It's unclear. The ambiguous case means that we could potentially get one solution. Could also get no solution. Or we could get two solutions. It's forward. That's really bothering me. How do you spell straightforward? I don't know why I'm having a brain fart right now. Somebody look it up. Type it in the chat. But that's one solution, no solution, or two solutions. I want to show you. It was with an R. Thanks, Jacob. I appreciate that. That's what I thought. It was bugging me. It was really bugging me. I'm sure it was bugging you too. And the ambiguous case means we could get one solution, no solution, or two solutions. I'm going to show you one example of each of those right now and try to do my best to explain to you why that's the case. Okay? So let's take a look first at an ambiguous case that has one solution. All right? Let's say that I'll give you another triangle, asking you to solve the triangle. We have A, we have B, we have C. I start with angle A is 68 degrees. I'm going to call this side 7, and I'm going to call this side 5. Okay? Just like before, no different than before, your eyes should be drawn to things that are across from each other. So you should see that these link up together, that the sine of this over this should be equal to the sine of this unknown angle over 5. So we can just go ahead and solve for that. We can say the sine of 68 degrees over 7 should equal the sine of C, which I now don't know, over 5, right? Cross multiplying here, again, you're just trying to eliminate the denominators. Multiply both sides by 5, multiply both sides by 7. You get 5 sine of 68 degrees should equal 7 sine of C. Let's divide both sides by 7. You get 5 sine of 68 degrees over 7 equals the sine of C. You may know now, again, remember, in order to get that C by itself, we have to do the sine inverse of both sides to get rid of that sine. Sine inverse. And so in a calculator, I'm just going to go ahead and plug in the sine inverse of that big expression. I'm going to do now the sine inverse of 5 sine of 68 degrees over 7. Again, making sure our calculator is in degree mode. And we get that angle C is about, we'll call it 41.5. So I'll say C is approximately 41.5 degrees. Okay. However, just like we saw with problems where we were doing the area of the triangle and we had to find that missing angle, it is possible that this triangle could exist in the second quadrant instead of the first quadrant. Remember, with sine is positive in both quadrants, 1 and quadrant 2. The reason Jacob just asked in chat, he said, why did you use sine inverse? The reason I used sine inverse was to get rid of the sine, right? In order to solve for an actual angle measure, we have to, in order to undo the sine of c, we have to do sine inverse on both sides. That's just like we've seen in trig problems where we have to solve for a missing angle, okay? So this is our quadrant, well, I'm just throwing my pen, I'm getting excited. This is our quadrant 1 answer. Our quadrant 2 answer, in order to find another angle in the second quadrant that would have the same sine value, is I would do 180 degrees minus 41.5 degrees. And you could say that couldn't C also be about 138.5 degrees? This is from quadrant 1. This is from quadrant 2. So which one is it? Well, sometimes the reason why this is called ambiguous is because sometimes we don't know. You're going to see that in an upcoming example where it could be both. However, it could not be this angle in this particular case, because if you take this 138.5 degrees and plug it into here, notice that 138.5 combined with the 68 well exceeds our limit of 180 degrees, which is what all of the angles in the triangle have to add to. How could it make sense to say this is 138.5 plus 68 is already like well beyond my 180, right? Plus an additional angle. So that answer in this context does not make sense. So there really is only one possibility, and that one possibility is the 41.5. Okay. Now I can go from there and solve for angle B as well as side B. I can say that, let's see, if this is 68 and this is 41.5, then I believe, if my mental math is correct, that that would have to be 70.5 in order to total my 180. You can go ahead and check quickly by doing 180 minus your 68 minus your 41.5, and yeah, we got 70.5, good. And then to solve for that side B, just like we've seen before, I'm going to refer to my sine of 68 over 7. That was my given information at the start of the problem, should equal the sine of 70.5 over B, which we don't know. Cross multiplying, you get B sine of 68 degrees equals 7 sine of 70.5 degrees. Divide both sides by the sine of 68, you get B equals 7 sine of 70.5 divided by sine of 68. Okay? We would plug that into a calculator, which I'm going to do for you right now. We got 7 sine of 70.5 divided by sine of 68, and we get about 7.1. Okay? And we were now able to solve for all angles and sides of that triangle. All right? Let me show you an example in which there are no solutions. You might be like, how the heck could there be no solution? Well, strap in. Get ready for this. What if I gave you this problem where, again, we have ABC. Just use those same letters. Just put them in different spots this time. We'll say that this is 70 degrees, this is 3, and this is 4. I'm asking you to solve the triangle. Just like before, your eyes should be drawn to things that are across from each other because they're going to pair up with the law of sines. We could say that the sine of 70 degrees over 3 should equal the sine of B, which I don't know, over 4. Cross multiply, you'd get 4 sine of 70 equals 3 sine of B. Divide both sides by 3, you get that 4 sine of 70 over 3 should equal the sine of B. To Jacob's point earlier, in order to get rid of that sine of B, I have to do the sine inverse of both sides. So we do sine inverse over here. And just go ahead and plug that into a calculator. We're going to do the sine inverse of 4 sine of 70 divided by 3. And I go ahead and hit enter, and yikes. Yikes. Rats. Rats. We got an error. But why did we get an error? That's a good question. Let's see what that value actually came out to be. That 4 sine of 70 divided by 3 actually comes out to be 1.25. So what this problem is asking is us to do the sine inverse of 1.25. What that question really means is you're saying what angle has a sine value of 1.25? And isn't that not possible? The largest value on the unit circle for sine is 1, right? That's the sine of 90 degrees, or pi over 2. The smallest possible sine value is -1, which is your 3 pi over 2, or 270 degrees. It's not possible to have anything that exceeds 1 or goes underneath -1. So what angle has a sine value of 1.25? There isn't one. There isn't one. So this would have no solution. And in fact, this diagram would not even be accurate because you wouldn't have enough to connect those things together. Like, you wouldn't actually be able to draw this shape. If you actually cut out something that was 3 inches long and 4 inches long and you made this angle 70, you wouldn't be able to make a triangle out of that. It wouldn't be able to happen. All right? Does that make sense? Hopefully. All right, let me show you the case, though, in which there are 2 solutions. All right, let me get a fresh piece of graph paper over here. I know we're approaching the end of our time together, so if you do have to run, I completely understand, but this is going to be uploaded anyway, so you can go ahead and watch back. But I would recommend definitely checking this out because it's important. Okay, just one piece of paper is all I need. All right, consider now a problem like this. Consider a problem like this. I have, make sure that paper is centered, triangle like this. We have A, we have B, we have C, we have 4, we have 2, and I say that this is 22 degrees. And I'm asking you one more time to solve the triangle. Just like before, my eyes would match up to things across from each other, so I'd say let's first try to find what this angle B is. The sine of 22 degrees over 2 should equal the sine of B, which we don't know, over 4. I can go ahead and cross multiply like before. 4 sine of 22 degrees equals 2 sine of B. Divide both sides by 2. You get 4 sine of 22 degrees over 2 is equal to the sine of B. We have to apply that sine inverse on both sides in order to undo the sine. In fact, if you notice on the left, 4 divided by 2, you could just write as 2 sine of 22. That's in fact exactly what I'm going to do when I plug it into my calculator. I can say this is the sine inverse of 2 sine of 22 degrees should equal B, and we get about 48.5. So angle B is about 48.5 degrees. But again, that refers to our quadrant 1 possibility. It is still possible that this angle could be constructed in quadrant 2, in which case B would be an obtuse angle. Let's take a look at what it might be. In order to figure that out, we're going to do 180 degrees minus our 48.5 to find another angle in the second quadrant that shares the same sine value. That would give me that B is equal to, again, if my mental math is good, 131.5 degrees, which is our quadrant 2 angle. Now, because these values both have the same sign, so it could be either one. That's why both of these, if you plug it in, would satisfy the equation. Now I would look up here and I would realize, well, it really could be both. We don't know whether it's 48.5 or 131.5, because if I plugged in my 131.5 plus your 22, there is still plenty left over for an additional angle. It's still under my 180 degree threshold. 48.5 would obviously work well too, because that's still under my 180 degrees. So in the case where both your quadrant 1 angle and your quadrant 2 angle are plausible, we have to split the problem into 2 and consider both cases. You may think, ugh, that seems like a lot of work. And it is like kind of a little bit more work, but it's really not that much. So consider in the case in which angle B is 48.5. That would mean we have a triangle that looks like this, more or less. Here's your A, here's your B, here's your C. This is 22 degrees. This would now be 48.5, and this would be 4, and this would be 2. We can now do just what we've done before in order to solve for this angle C and then figure out the side across from it. Angle C would be 180, take away your 22, take away your 48.5, and you would get that it's 109.5. And then you'd solve for the side across from it by just doing the sine of 22 over 2, always going back to the one that's given to us, make it a 2, not a z, is equal to the sine of 109.5 over c, which I don't know. Solve for that by cross multiplying. C sine of 22 degrees equals 2 sine of 109.5 degrees. Divide both sides by sine of 22, you would get 2 sine of 109.5 degrees over sine of 22 degrees. Plug that into a calculator, and I would get, I'll do it fast, 109.5 divided by sine of 22, you get 5.0. We'll call it 5. Okay, so that would be 5.0. Hopefully that makes sense. Yes, I know we're a little bit over time, so if you do have to run, I don't blame you. I won't hold it against you. But I am quickly just going to solve for the quadrant 2 possibility. And if you do want to stay for any additional questions on the homework, please feel free. All right. So my quadrant 2 possibility would therefore look like this. That would be where B is like an obtuse thing, right? Here's my 131.5. We'll call that B. Here's A. Here's C. My 22 degrees. My 2 here, and my 4 here. So now we're just considering, well, what if B were 131.5 degrees? What would the rest of the triangle actually look like? Well, it's the same exact solving process as you just saw over on the left. The sine of 22 over 2 should equal, oh, I need to find what this angle is first. If that's 22 and that's 131.5, I should be able to do 180. Let me not hold the calculator all crooked. Minus 131.5 minus 22 should be 26.5, right? So I can say it's equal to the sine of 26.5 degrees all over side C, which I don't know. I can go ahead and cross multiply to solve. C sine of 22 degrees equals 2 sine of 26.5 degrees. Divide both sides by sine of 22, you get C is 2 sine of 26.5 degrees over the sine of 22 degrees. Therefore, you get that C is equal to, one last calculator, plug in here, 2 sine of 26.5 divided by sine of 22, and I get, whoops, about 2.4. Okay? So in this case, where both your quadrant 1 and quadrant 2 angles are possible, we do just have to consider both of those cases separately. We have to say, well, what if it were an acute angle and what if it were an obtuse angle? They both could make sense and they both could construct a triangle with these sides. All right? Again, just like we saw at the beginning, if you're given, where are we here? If you're given just the 2 angles and a side, well, then it's a very straightforward idea. Oh, it's right under. I was just looking for this first sheet here. If you're given 2 angles and a side, it's a very straightforward idea where you can just go ahead and find the third angle and find all the sides across from it. There is no ambiguity. It just has to be the way it is, right? Unfortunately, though, if you're given two sides and an angle, that's when it becomes ambiguous. Since it's ambiguous, we have to first see what actually makes sense. In our first example, we saw that there was only one possible angle that really worked out. The other one didn't make any sense because it exceeded your 180 degrees. So we really only have to roll with that first one. In our second example, we saw that even one example didn't even work out because it was asking us to find the sine of an angle that wouldn't exist. So it wouldn't be possible to construct a triangle like that. And in our third example, we saw that both of these angles could be realistic possibilities. And so we found the sine of both. We just had to roll with both of them and see, well, what if it's this and what if it's this? Then this would be this triangle and this would be this triangle. So that's how it's done. Again, I apologize for going a little bit over. I know we went 5 minutes over, but I do appreciate those of you that stuck around. If you missed it, then hopefully you're watching it back after the fact. Again, a little reminder that there is practice posted on Classroom. It is my office hours now, technically, so I will be here doing any additional questions that you have on the homework on the area of triangles. There is, again, practice problems. Make sure you sign in for attendance if you haven't signed in for attendance. And that's all I got for you today. All right, thank you so much for your attention and focus. Next time we'll be learning about the law of cosines. All right, so gear up for that. Thank you, everyone, and have a fantastic rest of your day. I will see you on Wednesday. I'm going to stop recording now.